is the thing. What you have to study, that is the representation of alternating quantities. So it is also I have explained in the classroom how to represent a alternating waveform. This is the waveform here. In the right side, you can see this is the waveform, and equation of this is Em sin omega t. That means its highest value is Im, and similarly the lowest value, that is minus Em. Okay. Now it can be represented with a phasor. It is the phasor representation. So how can it represent this waveform? You can see that the highest value, that is Em, that can be taken as the radius of the circle. That means this is the value of this much Em. Okay, so this arrow line, this maximum line will be Em, and this will rotate according to the movement of this waveform. That means when it is at this point, this will be like this at 0. Okay, that means theta is equal to 0. As it is goes on increasing like it will goes on moving from this point towards this point. So at this point, when this time period is omega t, means after omega t, the value of this EMF is how much? That is this point. Okay, so similarly you can see this phasor is rotating. After omega t, this phasor will come to this point. So that means it is the magnet. This value is equal to this value. Okay, similarly, as it goes on increasing the time, you can see it will goes on increasing the value. Similarly, here also it is going on increasing the value from here to here. At the time of pi by 2, that means 90 degree, this will get the maximum amplitude. So at that time 90 degree, this phasor will come from 0 to this position. That means at that time this phasor will be at this point. That means highest value it will get. Okay, so this is the maximum value Em. Again after that, this value will again comes down. Here you can see again, if this phasor will rotate in this direction, this magnitude will again decrease. Then it will go for the negative values like this. This negative values goes on increasing up to minus Em. So here at this point it will be minus Em. Okay, then again it will goes on decreasing in the negative direction. So here again this will goes up. Okay, like this. So at this point again it becomes 0. Okay, so in this way we can represent this waveform with a phasor with an angle. That means if this is the reference line, then it will show the angle at the particular time when we are taking the magnitude. So this is the phasor with the angle. Okay, now if we are going for two waveforms of same frequency, that means both the wave phasors will rotate in the same speed. Same frequency means same speed. In the same time, they will complete one rotation. Okay. So for this one, this is the waveform, smaller one, and for this big one, this is the waveform. In this figure, you can see it. Okay, now see, because its magnitude is more, here you can see it is the highest magnitude is more, and here its distance is less than this one, so here its highest magnitude is less than this one. Okay, and this frequency is both as having same, so here this frequency is of both the waveform are same. Now what is the difference? That is, difference means this E is lead the current I. Voltage is leading the current. That means here you can see this is the voltage waveform and this is the current waveform. So it is leading by alpha. So how much degree it is leading? This is alpha degree from this phasor to this phasor. So this is the phase difference. Okay. So alpha is the phase difference between these two waveforms. So if you will write the equation, now you can see for the current it is Im sin omega t because current is taken as the reference and voltage is leading. So we can write down Em sin omega t plus alpha like this. Okay. So this is the phasor representation.